Hey, it's Mr. Shrum, and I'm back again with a physical science tutorial. And today we're going to look at properties and chemical reactions. So this will be a fun one. We're going to determine whether a chemical reaction has occurred by comparing properties of reactants and products. That doesn't sound as fun, but it'll be a little more interesting than it sounds. So, for a warm-up, if we pass electric current through water using two electrodes, the water breaks down into two different substances and a chemical reaction occurs. And these two different substances that water is broken down into is hydrogen gas and oxygen gas. Bubbles of each gas form at the two electrodes, and we can collect the gases and reverse the reaction easily. When we light the mixture of gases with a spark, they burn and form a single product, water. So you can pass electric through water and separate it into the individual components. All right, so a question: which chemical reaction involving water is a decomposition reaction? Decomposition means breaking up. And the opposite of that is synthesis. That is when things come together. They're building up something else. And if you're not sure, take a guess. All right, so water breaking down into hydrogen and oxygen is a decomposition reaction. You have a thing broken down into smaller things, and then you have smaller individual elements combining to form a big thing. Water, synthesis, decomposition. You'll get the hang of it in no time. But first, we're going to look at what is a chemical reaction. What's going on under the surface? We see something, but we want to understand why it's happening. And sometimes we can't explain all of the events taking place around us. And one kind of event that is hard to explain is a chemical reaction. In a chemical reaction, original substances undergo a complete change into new substances. This change in substances fascinated early scientists because they couldn't understand them. Henry Cavendish was an early chemical experimenter who carried out chemical reactions in his laboratory or lab. During his experiments, Cavendish discovered hydrogen gas and tested its properties. He found that hydrogen burns in air to produce water, and that the density of hydrogen is lighter than air. And we have a video here to learn more about the life and personality of Henry Cavendish. Let me share the computer sound. We should be good. Put the captions on for the people. Yeah, so that's Henry Cavendish. Short little video, but interesting nonetheless. And let's move on to chemical reactions and substances. People are fascinated with chemical reactions because they help us find and create new substances. So it can be very exciting for people. As a result, people have identified over 50 million substances, and all these substances are made of just 92 elements. And these elements can combine in various ways to create all those other substances. Most substances are compounds that include more than one kind of atom. Many chemical reactions result in compounds. Some of these compounds, such as water and carbon dioxide, are made naturally. They form because of chemical reactions that occur in living organisms and during natural occurrences such as volcanoes and lightning. Other compounds are synthetic. They've been made in chemical reactions carried out by scientists. And synthetic compounds include plastics, medicines, and preservatives. Describing chemical reactions. Building an erupting volcano is a popular science project we see in movies and film. Adding baking soda, solid, to vinegar, which is a liquid, gives us carbon dioxide gas, CO2. And the CO2 gas rises up in the form of bubbles and looks like an erupting volcano as it flows out. Here, the original substances, baking soda and vinegar, are reactants. The new substance, carbon dioxide, is the product. Reactants are the things doing the reaction. They are reacting. A substance that is present at the beginning of a chemical reaction and is then transformed by that reaction. And then we call the end product the product of the reaction. So we have reactants on the left side here, and then we have the product on the opposite side. And this is a chemical equation. It represents what is happening in the reaction in a sort of mathematical equation. All right, testing your understanding. A reddish layer of rust can form on old iron nails and bikes. In this chemical reaction, iron reacts slowly with oxygen in the air. The chemical name for rust is iron oxide. What are the reactants and products of this reaction? Write down the equation in words for the formation of rust. And if you look at the answer, we have iron plus oxygen equals iron oxide. Anytime you see oxygen being added, you'll be very familiar with this oxide naming convention. Iron slowly reacts with oxygen and forms rust. In this case, the reactants are iron and oxygen. The product is rust or iron oxide, and that is the equation. A chemical equation is a powerful tool that we can use to write a chemical reaction in words. The substances can be described using everyday names or scientific names. So for example, here's the equation for baking soda and vinegar using their chemical names. Acetic acid plus sodium bicarbonate turns into, it reacts and becomes the product carbon dioxide and sodium acetate. We can also write a chemical equation using chemical formulas. Chemical formulas are a symbolic way to write substances. Every substance has a chemical formula. For example, the formula for water is H2O, and the formula for carbon dioxide is CO2. Observing a chemical reaction, you will compare and contrast information from a video with information from a text. You will write an explanation of a process using precise language and vocabulary. So here we go. Now that you know more about chemical reactions, watch this video about the experiment that Henry Cavendish carried out when he discovered hydrogen. Then we're going to answer those questions. All right, I'm sharing the sound. Turning captions on. Okay, so you can see how scientists have fun with stuff, and a lot of science is just being a little creative and curious and carefully trying things out. because sometimes things can go wrong. And let me close out of that too. Oops, just kidding. All right, so what was the main aim of Cavendish's work? Well, he wanted to work on figuring out the weight and measurements and classification of objects around him. That's all he wanted to do, was weigh, measure, and classify things around him. What were the reactants of the first experiment? Well, in that first experiment, he used the metal, remember, zinc, metal, and hydrochloric acid. He poured that on top. That created a gas. Then he filtered that gas into a dish of soap, and those bubbles were filled with that gas, and then he lit it on fire and it popped, sparked. During the experiment, what evidence showed that a chemical reaction might be occurring? Well, the zinc appeared to break down and a new substance, a gas, appeared to have formed. Part D, Cavendish's name for hydrogen was inflammable air. Inflammable means to burn. Note that in is not a prefix in this word, so it's kind of a weird word. Why did Cavendish use this name? Well, the gas formed in the experiment could catch fire easily, so he named the gas inflammable air, air that could catch fire. What word chemical equation describes Cavendish's experiment with zinc? So this is an easy way to put it. Zinc plus hydrochloric acid reacts and turns into hydrogen and unknown substances in the flask. So we don't, as a scientist, you don't know what those unknown substances are at this moment in time. Cavendish carried out a second experiment to test the properties of the hydrogen gas produced in the experiment. Was this experiment also a chemical reaction? Yes. So both of those experiments were chemical reactions. The original substance, hydrogen, disappeared and a new substance, water, was formed. What word chemical equation describes the second chemical reaction? So we had hydrogen plus those unknown substances in air, and that turned into water, or hydrogen plus oxygen equals water. Now we're going to talk about evidence of chemical reactions. In the experiment, Cavendish performed a metal solid and an acid liquid reacted to produce a gas. In any chemical reaction, substances interact with each other to give new substances that have different properties. In the Cavendish experiment, the product, which is the gas, has properties that are different from the properties of the reactants. Release of a gas can mean that a chemical reaction has taken place. When carrying out a possible chemical reaction in the lab, watch for such clues. There are 4 different clues that indicate a chemical reaction has taken place. They are a change in color or temperature, release of a gas, or production of a precipitate. Okay, so color, temperature change, release of a gas, or production of a precipitate. And a precipitate is a little solid that forms from mixing 2 liquids. So if you mix liquids together and there starts to form a little solid something, there is a chemical reaction taking place. More answer keys. Which of these events indicate that a chemical reaction might have offered? Which of these events indicate that a chemical reaction might have occurred? Why did I say offered? Silly. Okay, so silver jewelry becomes dark because of tarnish. Now, tarnish I'll show you what silver looks like and then tarnished silver. So here's, yeah, here we go. So silver, and then you can just see how tarnish develops. And there are ways to remove it to some degree. All right, let's get back. And a solid appears when two water-based solutions are added together. When silver tarnishes, the color change. When silver tarnishes, the color change shows that a new substance is produced. Likewise, the precipitate forming from the two water-based solutions shows that a new substance is produced. So those two events are chemical reactions. Sometimes observing clues like a change in color or temperature doesn't confirm that a chemical reaction has taken place. For example, adding a drop of red ink to a glass of water changes the color of the water, but no chemical reaction is actually taking place. To definitively determine that a chemical reaction has taken place, it's necessary to carefully test the properties of reactants and products. Each substance has a unique set of properties. One of them is density. We can determine whether two substances are the same or different by calculating and comparing their densities. No two substances in their purest form have the same density. All right, more question understanding checks for you. A scientist compares two samples of colorless gas present at the beginning and end of a lab process. She wants to determine whether a chemical reaction has occurred. She tests whether each gas is flammable. Neither gas burns when lit. She then measures the amount of each gas. Sample 1 has a volume of 53 cubic centimeters, cubic, the 3, so that's a volume, and a mass of 0.10 grams. Sample 2 has a volume of 39 cubic centimeters and a mass of 0.05 grams. What are the scientists' findings? Density calculations show that the gases are different, so a chemical reaction occurred. Appearance and the flammability test did not distinguish the gases, so we must find the density of each gas by dividing mass by volume. If you recall, density equals mass divided by volume, mass per unit volume. So in this case, we have 0.0019 grams per cubic centimeter, and sample 2 has 0.0013 grams per cubic centimeter. Because the densities are different, the two gases are different substances. Therefore, a chemical reaction occurred. And I'll stop there for today, and I will see you all next time, and we'll finish up the other day. Okay, see ya, guys.